Today we'll start talking about special right triangles. There are two types of right triangles that we consider special because they have special properties that allow us to find a missing side with limited information. The first type is a 45-45-90, and that means it's isosceles. It's a right triangle because it has a right angle. The two legs are congruent, making the two angles congruent. Remember that when the two legs are congruent of an isosceles triangle, the two base angles are congruent. Therefore, since they have to be 90 degrees, 90 divided by 2 is 45. So we know that the legs are congruent. So I'm going to say that if a leg is x, that's the length of a side, both are the same, then the hypotenuse has this special relationship that says whatever the leg is, whatever x is, you multiply it by the square root of 2, and you get the hypotenuse. Therefore, if I just know one of the sides of a 45-45-90 triangle, I can find the others. So let's look at some examples. Since this is 90 and this is 45, I know this is also 45. It's a 45-45-90. Therefore, the two legs are the same, so x has to be 8 since this side is 8. And y is the hypotenuse because it's across from the right angle, so it has to be 8 square roots of 2. On this one, this is 45, so these are congruent. That means these are, so y is 25. X is the hypotenuse. It would be 25 square roots of 2. These are easy, right? Then if I know that the hypotenuse is 9 square roots of 2, then the legs have to be just 9 without the square root of 2. So if I know a leg, I multiply by square root of 2 to get the hypotenuse. If I know the hypotenuse, I divide out the square root of 2 and get the legs. Now this one, I know the hypotenuse, so I need to divide out the square root of 2 to get the legs. But what we learned last week is that we don't want to leave a radical in the denominator or a fraction in order for it to be fully simplified. So we have to do what we call rationalizing the denominator, multiply it by itself. In order to keep it equal, I have to do the same to the top and the bottom. So I get 28 square roots of 2 over 2. 28 divided by 2 simplifies to 14. Therefore, both legs are 14 square roots of 2. And same thing on number 6. 19 is the hypotenuse. Divide it by square root of 2 to get the legs. To rationalize the denominator, I multiply both by square root of 2. I get 19 square roots of 2 over 2. So I can either write 19 over 2 square roots of 2, or I could write 19 square root of 2 over 2, or I could write 9.5 square roots of 2. I would accept any of those answers. Let's look at a word problem. You've got a baseball diamond. I'm not the best drawer, but I do know a baseball diamond goes like this, and that there's right angles here. The distance between each base, that's here, is 90. Because it's actually a square or a rhombus, I guess it would be a square. What's the distance for a throw from second base, here's first and second, third, and home, to home plate? So isn't this the diagonal of a 45-45-90 triangle? Yes, it is. So 90 square roots of 2. But if someone asked you to measure the distance and you told them 90 square roots of 2, that wouldn't mean a lot to them. So for purposes of a word problem of telling people something that they can understand, we actually put that in our calculator and turn it into a decimal approximation. So, sorry, let me get my calculator going here. 90 square roots of 2 is about 127.3 feet.